Maybe how do that's really stuff there. This source I private how we introduce it to Paola. And Paola will tell us about introduction. Take it away, Paola. Thank you very much. And related to the critical condition, okay, so I am thinking and populations are sequence and spectral time. So basically, the P enter by the P bound correspond also to systematically hardware and exploration of the there is about 4,000 kilometers per second. So that the population is almost like so this is the finally similar. So there are many combinations in sequence. I don't I cannot really talk about many of them. I don't want to say that in the consequences, the negative factors on sequence is not actually anything. Was basically based not manually the novel of Stephen King was the inspiration for the movie. And I want here only to express a couple of things related to the volume part. And I want to stress the systematic changes for the communication time and data and the differences between the law and RNA. Regarding the systematic differences, we can see that the movement from the spectral type of population being passed on the right, is a file, is a line of time. And in the case of 4, we see that the sum of population A, while there is no correspondence with the time. It's almost completely so let me briefly introduce also a model that's been applied to data to try to explain critical picture. I think that's the one is. And the most recent is on the play role that is basically we can have wind, and you can see here that there is those between dimensional the sequence of the one-to-one correspondence between the dimensions and the dominant for single government can be knowledge using the flavor framework and this not very well orientation in maths and even the fact that we can sample and that comparison we go toward the narrow times and we in this case we see that the big parameter se pubblica al massimo over sigma is developing for that tende to zero and correct the risultato in sigma and the observer the opposite observer the most example. This data, well, let me consider that the scenario taken on an innovation with the effect of mass and meditation taken into account was able to introduce what we consider in so, from this, what happened if we go at the office in where we set the data? To be same, we selected a sample of more than 50 pages of data. Extremely now over 47 percent from the and this is the sample of data to populate, let's say, regular population in the minority is of the body flow. Here, review the loss of and we use the phenomenon the observation data for the infrared and at the same point we compare the hybrid antennas that can model the emission and so what we found was the supply of the almost dependent on the location and here we see again the provider of 4 in each data base. We see how typical is the line of carbon 4 with respect to the data. Also for the cases in which we have a strong value of asymmetry in data. So, and this data are very much consistent with the idea of a so image specifically of calcolo sostituire possibly calculations. So, what is the physical mechanism to produce this situation? Well, I think that reason implies that the systemic velocity partially proportional to the velocity at the long area multiplied by the square root of multiplied by the innovation. If the function radius velocity is also available, and if the function radius follows below the square root of the denominator, then I will contain the condition of the integration. We see that the term velocity is part in the format with the best data, correlation analysis, of course, all the data which we must should be more the observation scientific revolution, and we got something that is the regolato da gestire quello che capta delle altre scritte e così c'è conclusione where sources remember systematically the smaller shift, but still the regular population is reaching several thousand per second. And this also mirrors the situation that we encounter at lower redshift. At any rate, going from long enough to hang out, serve systematically increase the shift into the this time from left. So what about A beta and what could be expected from this regard on the A beta? Well, we have a situation we according to customers. We see that the billion mass is the billion mass implies, along with the scaling law to the arm, related to the probability, with one quarter terminology alienated to one quarter. And if we consider it as much as possible, because the correspond to the maximum minimum, we can have lower relation in which we see that the right people seem to fit better. Probably very well is meeting the line or under which particular not encounter anymore. In the desert, so another interesting aspect is that sono asimmetriche. We can compare two aids over 6 order of magnitude in linearity, and we can go into the lowest linearity up to the highest, and when it becomes more symmetric important. And we measure the symbolic one order, the critical action, and we see also the prevalence of the symmetric profiles is increasing. So, well, what to better define this phenomenon, we attempted to correlate the five with mass. So, the thing of water, you can see, but we can clear that up to a sample character, above which at least the increase of symbolic towards maybe and the that are corresponding to about 1,000 kilometers. So, what is the origin of this shift? I think that there are two main competing involved. And the big one is the gravitational phase. The first is independent on the plane, and the other thing on the gravitational phase. In both cases, with the inverse square root of waves, and the length of the engineering but in any case, it is very convenient to think of in a flow that is and about uniform, this is supported by observational campaign and obtain the velocity control rotation, and you will see one of the scales. They are not all like terapia tecnica, per cui o assumere che riuscita indiretta, e si visita di rendering is responding much faster with respect to the rest of the line. Implying that the gas that is executed is closer to us, and I think I have seen possibility to start. So, but we can expand the and take into account the different ratio depending on the needs to be inspired equal and on the needs to support the stream. So we take a different dependence on the mass elevated to 100 and 1 quarter for the gravitational and for the continuity. And this is that when you go one then basically for fixed physical condition, the gravitational actually increase particularly the class reaching the problem of the industrial law instead of the gravitational relation follows much more slowly with an inverse trading flow. And doing this check when trying to best example with very clear display profile and including most of the data on any salary, we obtained a total of the relation between the target one quarter and the mass that is consistent with the gravitational metric. Also, we can find the syncroid bandwidth to expect something by 0.22 and for the gravitational action, and we see that the data are not consistent with the state that So my final considerations are that we superillusions technically allowed for the detection of clear signature of two physical processes. One is stated with the presence of repetition living. At the same time, we detect for the low derivation part of the one and it's associated with the usual assets that are involved in the central response. And so I can say that the extreme luminosity and mass involved in the division of the element of one sequence as much the balance between radiation and gravitational force. And selected also moving near the roots, no stand for the particle, and I think it's because the second one is the consideration of the richness of the relationship of human culture and the third one is respect of human without this evidence. I think that which will say very difficult document. Thank you very much.
I very much so about what is the big difference between the power board and the issue. The global, which is the mission.
Three information is of right long emission. This emission can go addition higher addition that t-shirt about the Thank you very much, Paola. We have Hartmut telling us about the ununified model. Take it away, Hartmut.
Okay, thank you very much. First of all, I really found it really very much interested in the conference with your answers. Okay, I told you. I'm switching to the speech for very certain things for the model of the APA. Basically, that's the unified model implying that what the difference between type 1 and type 2. So basically, nothing about the orientation is having to be looking at it from a different angle. Apart from that, very few differences. If that was the case, then you moving here, but nothing can be minus one others. So what I'm going to try and show you is it's fine with what I'm very the interpretation, but I think there's a whole lot more that one can look at when one looks at it. And that as a result of those, so that's what's been going on in the region of the So it's what's one minds really different. This more is difficult that one. The sentence, and I'm highlighting things everybody agrees. There is monoline orders, narrow lines, but still, you'll see how it's happening. We get our lines of all other effects scaling numbers as well, whether it's time to one we have, or whether it's time of emission, log. One it's on the parts of downside. So it's something to recognize, which what I'm hoping is also incorporate in the model that I've got. Also, the difference with some objects, we mentioned of narrow type 1 sequence and so on, all that cannot be text to a unified model, so we need to also be look at a bit more. Okay, let's start with the last book. And I'm putting a picture from the for the involved. And I'll explain it early on. There's an extreme population, an extreme population. And so on, basically, that depending on what's the strength of the iron line, is that what the width of the board is, it will tell you something about what's going on in structure example. Notice, by the way, that if we constantly narrow lines to this way, it shows the typical sort of iron lines. And what I'm also going to tell you about those objects, I'm going to give you some sort of indication about without looking at the list of board problems that's here. I'll give you some sort of indication about what percentage could fall under a particular class. The full definition behind something I'm trying to do is get formalized for mathematical relation. But I'll come to that later on. But if I look at important narrow line sequence, it's roughly putting in the state of the types of timelines. And we talk about stronger than usual iron 2 lines. We're talking about roughly 15% what I've found. Okay, so we then come to a couple of the techniques. So This is something I think we should that's we just look at the in-house all the lines in different types of spectra. And depending on how they're a little bit broader than the hash lines, exactly how many gaps. It gets to be that they can the speed which they or something like that. Then the is what we talk about strong corona. This is a nice example, it was a very well known. Again, if you look at the lines of 3 dots, those are all caused by simple corona lines. You'll see that it's another. Now, why and what can one learn from it? Okay, this dot is slightly more, the blue dot is slightly more, this is here, this is here, this is here. If I use it just by eye, of course, the bigger you stick from the more you line may be able to identify. But if I just by eye, I would say the number of objects that we did with enhance, if we brought here, we give our 4, and one will correct roughly 2%. That's what I found so far. Okay, just to show you that all not all 18 on the set, we did find some really good holes. This one over here is spectrum counterpart development. These from the bottom of this example I mentioned here, these lines are going to be on the very same corona. I think especially people will deal with it, maybe they will say this one is stronger than 8 meters on. So what exactly is going on here? It's one of the really days. So maybe I thought, no, work company here, a lot of people working on this and discovered that one of the people is of the something popular. You need to advertise today. So it's somebody else who really. In addition to the extra spectrum, one completely spectral lines is slightly bigger. So I like this quite to take a spectrum on something now, saying we need to do more normal. Again, okay, what's going on here? The fonts the fact might be part of the structure. So basically, there are lots of very different kinds of stuff. They expect around the world to indicate some process going on. Okay, here the next category I want to look at is PAs, the model profiles. Here there is some examples given. Especially rotational these double buttons over here. This would be a great example of that. Plus, it also rather wide as well. Yeah. So here, this is to give this page up. You can see it very nicely. It sees that the broad which goes all the way beyond the socket and up to oxygen 1 over here. So it's over here, you start to get a lot of questions reading this one. It's very unusual profiles. One fraction of all this and unusual profiles very far removed from calcium prevention. I would say about 5% is what I think. So the plants come stronger than you like this. It's stronger than Scotland. It's that's what you'll typically find in lines. I would say about 70% of the core line that I've seen in my sample conform with that. And then some typically mentioned the whole question of reckoning and how does steering play a role in some of the number one. And in particular, it's got an extraordinarily large difference. So I think the example is about 10 times from that region. Indicating that with pretty high limit, you'll see it's got very much the fact that the continuum is very strong in the red, but in the blue. And a couple of absorption features over there, which one typical, this would be sodium, and this would be calcium, so then you'll find, so that's a good indicator of absorption in the system. Okay, then people have mentioned earlier we talked about stars happening in galaxies. In the 3D would be that spectrum very close to the ADN or one might just end up with some sort of actually contaminate the system itself. But typically what you'll find broad lines and very narrow lines to the end. You can see it's good examples happening. Okay, so now back to the part where I want to actually analyze things. The first thing I'm trying to do is to actually get a good measure of the continuum. And what I'm trying to do is identify areas of the spectrum where you don't have any emission lines. And particular ones like orange, also nice spectrum, and you see conform to areas with very different types of spectrum of don't have side of the emission lines over here. These ones over here, they're a little bit more dangerous, because we have very broad lines. We find that they get contaminated stands, but it's something that might be fine for use as well. Okay, then the next thing I want to look at is what is exactly the host status when you take the spectrum of the APE. Because normally we try to remove that to actually evaluate what you want to live. There's several things you can do that. I would be interested to measure how strong the calcium lines are, or how strong the G-band are, or the step over here, the force out extra break. So again, so my approach, try and find areas in the spectrum where you can systematically fit your lines to actually measure a particular quantity. I put in here also because here we talk about the option 2 way of determining this solvers activity. So get to that, this one relies in here, so you need to be able to define a quantity in some sort of consistent way, and then take the measurement. All right, so let's put one of that. And here's something else. We were talking about the strength of the iron lines. Now, I think the original measure is specifically goes from here to here. Okay, I don't think it's although that's the historical way of doing it, so the group had used it. That's rather first go to 81 BH gamma, then that's go to BH2. So I think this might be a different way of doing it. What previous studies have done. Something else one can do when it comes to measuring how strong or how wide area you might, especially when you're dealing with iron features. This spectrum can one object which has very strong iron lines. Notice this one too, there is this iron here, but you can't separate it into the individual lines. So in this case you can. So I suggest that measuring the strength of the spectrum at these points is a good way of indicating how strong iron will be in these cases. Okay, so what I'm this goes almost 8 years now is that I had in total 62 weeks of telescope time. This is the sum of 1.9 telescope. This is 1 year. It's not bigger than itself, but it's it looks like it's still really a very large building. I think it's from the 1930s or so, but the spectrum is really good. So this is what we got. Standard kind of work, cover the whole spectrum basically, use the standards, the circuit, and this is the gentleman over here is one who's actually doing most of the work with this stuff. Therefore, 62 weeks, they've been doing it. So, they all this life basically of everyone else. Okay, so apart from the data and output, we've got something so difficult stuff here. You know, we come to the areas that slowly created all the more spectra are there. Obviously, one of the units source identification project are that's still being finalized, but having issues spectra will fall under that. So what I've done in each case, I'm trying to do a spectrum which I never convert it into format, so that one can be used to say procedure for it. For very rich, I've used a template which I don't see many other people use, but I find it's fun because it combines. It's not just a kind technology used by a lot of people, combined with a liquid, and then I have the extinction and galaxy correction. Okay, just as far as I complete this consider catalog. So I've got the catalog of and about 2,000 resources. In there, how complete is it? If one somehow assumes that the very low level area between here gets 100% complete, I'm not sure it really is. This is what we've been looking at. And this is the total I would expect to get in the catalog. It's how much they upload at the moment. It seems that was about 30% complete, and not surprisingly, those further around because increasing. Realize picking up almost everything we can as income. Not all of the really waiting for an area that says some sort of black hole. Okay, what I'm still missing is about 500 spectrum. These are both northern and southern ones. So in the sun, we can go off to about 20 degrees. These ones are planned to observe Musk. UNISA will probably are my unity after we finish there. And in the north, well, there's anybody who is opportunity telescopes available in the north, or we do some sort of swap agreements in we don't learn from the south, whatever the sources they might be interested. We can talk about it. And then just to mention that in a big catalog and variables, some topology, because 1.4 meter telescope window situated here, and so what I typically do is get try and look at object and speed at the oxygen radius aperture, and they are so far I don't even know how many models of else in the time, probably it's well over 300. And so catalog about 70% complete. So that's by next year or so, that will be completed as well. Okay, so I'm coming to the catalog. This is what it actually looks like. Yeah, by the way, the older people in this room will remember the Neuron City catalog. It used to be the place to go to any kind of list of maybe that. Of course, given the exponential growth in the discovery of thinking, it's not surprising that the Neuron City developed eventually. And so they with the team. So what I do is to go to stay within the system distance for us. You can probably have some sort of chance of media. That's why for Z limit. So that Z of 1.1. So it appears it's some sort of hope that one can actually complete that one in some sort of foreseeable time. This is what it looks like. It's got pretty much any this is type points. It's very type one that was discovered. I've given it some sort of spectral coding. As far as what I also try to do is to, because usually you actually look at the spectrum, then you're really to see what it is. Rather than somebody to type one or whatever, it's easier to look at the spectrum. So the moment it's in a spreadsheet format, you just put your mouse on there, this is what you'll get. So you'll be able to see on the spot what exactly you're dealing with over here. So most of these spectra are either from CERN or there's spectra which I've collected myself. I'm not quite sure about other sources, but I can possibly look at those, but there's I prefer to stick with those for the moment. So here's some of the topology where it's available, but it's not. And what I intend to include here, and that's still needs to be done, is to raise those which describe some of the characteristics and some of the considered. For example, if we want to describe an agent that says strong current, how much we do this? Okay, which line do we use? Maybe more than one. Where do we find the continuum of difference? So I'm still thinking about it, and I don't want to commit myself into it, otherwise it's going to be difficult to change that. So if anyone has any particular idea about how this should be done, you're welcome to hear it. I'm hoping to bring out the next version of this catalog in about 6 months or so. So when we go to practical good, which doesn't have all of the other information over here. And with that, we just come to the films. Okay, I'm in the old school, so I believe that films should be more than entertainment. That said, I'm afraid there's not that many things I have any films to choose from. What I found is really a film that's a series on a page and on the reader, because it was the same of my fellow colleagues. And I remember the fellow with the sports. So it's found that for this particular series. It is quite hard to make, but I haven't been able to see it because it's a problem with nature. What I think I got very strongly, knowing that I was this I looked again for the second time at 2 of these films on here, both of them with this person. And that real true artists, one of the original artists, events, yeah, I don't really the role is and with not only that, it's more entertaining, it's very, very well done. Yes, you can probably watch it. Okay, good. Then I'll finish.
Questions? So how many Asian do you have?
It's over 2,000. It's about 2,800. That doesn't include some of the ones that the rejects in a sense. So the ones which were sometimes have been educating channels. So when you reach those 12 ones, sometimes to about 4,000.
Also, region, you know, they are
okay, in the catalog, I've got pretty much anything which is report to the DGA and also there's no that discovered this doesn't want to get it in this. So that's all the catalog of this movie. When they were discussed, they put this because they want the most of the parents not right. So that's why many of the entries they are still I can't find the actual picture in the literature. So
really appreciate the detail you went into this. But general comment, if you could talk about all of those some people may not be aware of this. So the JWSC giant population illness can be similar to the Netherlands. In the sounding phase, the fast generation modern time computers. It's really but it's signature, it says in the sense of as the Iceland, which is iron is on the we will continue to study basically the very birth of the youngest stage of being analysis of narrow lines, some extreme cases, they can go off. Felicity truly seeing we go very rapidly.
Yes, given that I'm actually speaking to the neighborhood, you don't see that. Yeah, I also don't see evidence of that focus of any changes in general conference. Because that's the same.
straight out from AO1, UV emission, UV emission. And today is about my master's work, which is about the emission. So let me introduce you to our important topic of this presentation, which is the questions. So this is a real command and organizes Quasar layers between raw elements. On the y-axis of this diagram, we have the moving capacity, the H beta initial line, and on the x-axis, we have the armor, which is the ratio between the optical ion to emission and the H beta H. Now, the next sequence would be like a muscle or type 1. It allows us to organize these objects into B group populations. These populations are population B quasar, located in the upper region of the diagram, and population A, located in the bottom. We also have a subpopulation of interest located to the right, this diagram, which is the extreme population A, also called SA. Now, as mentioned before, the main sequence would be a manifestation of three main effects. First, we have a trend with the black mass, and according to this, population B quasars tend to be more massive than population A. We also have an important effect with the accretion parameter. According to this, the accretion value increases in the horizontal diagram, and because the objects in this region of the diagram are going to radiate very close to the element. And finally, we also have a trend with Zihuagn. According to this, population B quasars are also going to be higher in emission than population A. Now, the main sequence trend has been historically lower as we increase the velocity, we begin to use active H beta and then higher to emission. On this videos, expectations for reference. So to work on this problem, my study wants to ask whether we can define equivalent sequence, but in the neutral. Because there are many observations of that range for hydrogen quasars. So we are studying a region of the ultraviolet spectra known as the 1900 Winkler. So you can see here, the blend is the combination of trees, aluminum tree, silicon tree, and carbon tree. And it is surrounded by the smooth iron tree and iron 2 features. Now, about these features, it is expected that the iron 3 emission will be more important than iron 2 in our study range. As we can see in this spectrum from Westergaard in 2012, most of the features are consistent with iron 3 emission. Now, we know two interesting things about it. And the first one is that the weight between correlates with the weight of the is that the iron 3 emission seems to be stronger in SA waves. So, knowing this, our hypothesis is that iron 3 and iron 3 will replace first. And together, they might define an ultraviolet sequence similar to the optimal. So, to explore this idea, we are fitting the ultraviolet emission, a sample of 1 HX. This sample has 70 objects of 70 gauges, and the sample has been studied before on the next sequence topic. So, as we can see here, we already know which objects are population B, population A, so on. Now, to fit the ultraviolet emission, we are using a code which is based only in CMP algorithm. In our code, we are using a overload, a level 2, Gauss and Lorentz properties, monoliths, and two templates for the ion features. So we can perform a spectral fusion to all objects in our sample, and this is the main result. We have identified an ultraviolet here in the above that mirrors the Quasar sequence. here in the left plot. Our trend is defined by the list of aluminum tree and the equivalent list of the top iron emission. Now, let's see, in our ultraviolet trend, each population from the original sequence occupies at least a region with minor overlap between them. So that provides an almost equivalent representation of the main sequence trend. And now, from the Q division provided by this study, we build a composite spectrum for each population. And as you can see, there are clear spectral images. In the big composite of here, the red emission is also considered emission. While in the next stage composite, we begin to see this double peak profile as the result of an increment, the series of distribution. Now, this analysis was compared with a careful experimental peaking and it started the switch. So, we have a clear trend in the lines prepared. But the thing that to highlight is that this trend has been recorded before. It is an result of the Quasar continuous. So we are effectively able to reproduce this result by using our data. Now, the composites also show an increment in the ultraviolet light emission from population P to XA. And as far as we know, this is something that has not been recorded before in our study range. So, in order to test if it makes this method, we run photoionization simulation with the cloud. Plugin is basically a software that can simulate the interaction between the AGM variation and the results of the property. We use plugin to simulate the action or representative objects along the sequence. The position of these objects are presented here, and as we see, they map different regions of the main sequence thread. And now, the physical properties of these objects were explained in the work of Florence 2024. So now we are using data results as input for our cloud simulations. And then from the simulated spectra, we measure the same parameter set in our observations. And the results are presented on the left table. And as you can see, the cloud simulations predicts an increment in the ultraviolet light emission from population B to XA. This increment is consistent with our observational trend. When we plot these simulated values in our data, they fall exactly what we expected. The position of each of them matches the original sequence classification. So, the cloud simulation somehow supports our interpretation, at least for these representative objects. Now, the final purpose of this study is to apply this at high level. So, as a filter, we have applied our methodology to 3 hydrogen choices. The first one is a regime 4, and it was observed with the PAola. And the other 2 are a regime 7 or less, and it works with J. And I want to highlight that the spectra of these 2 objects were actually worked by G. Here is the spectra and the resulting spectroscopy for these 3 hydrogen choices. Here, the red line shows the left model and the yellow molecular distribution of each H2 line. Here are 2, we can see the color of each line. Now, as you can see, the 2 objects on the right have a stronger ion emission than the one on the left. Now, even more interesting, the 2 ion rich quasars have a strong aluminum and a strong helium, while the one on the left is mostly dominated by the ion distribution. So, if you remember, this is the steady trend that we saw for composites and converge. And now, when we place these 3 quasars in our ultraviolet trend, the 2 ion rich quasars fall in the XA, and the carbon-2 dominated one falls among population P. In addition, we have checked the electron radius of these objects from the region. And now, the final purpose of this study is to apply this at high level. So, as a filter, we have applied our methodology to 3 hydrogen choices. And the 2 ion rich quasars fall in the XA, and the carbon-2 dominated one falls among population P. In addition, we have checked the electron radius of these objects from the region. And the two XA candidates are splitting the quiz. So, despite being a much higher range, these three objects to follow as their trend. But of course, this is a very preliminary result, and we need to test it on a much larger scale. So, in summary, we have identified and tracked the split quiz organizations. Our objective is defined by the list of aluminium and the equivalent list of horizontal illumination. We have performed other simulations and the results come out to support our interpretation. And we have applied our methodology to three hydrogen quasars. And the result will show consistency between the trend and low range. For the future, we want to apply our method to new samples in order to validate these results. And we also want to run a new class simulation for new models in order to build strong conclusions about the nature of this illumination. And finally, I want to thank my collaborators in this work. And about the movie, well, I am from Chile, so I want to look for a movie from Chile, but I couldn't find any. So my recommendation is it is that and objects and also more and that will be now we have a lot of questions.
Plus 6 people, Salvini, with the other classes, right? So, yeah, how sure you get? I mean, see how much later or going through what of 15 how much files or affect your results.
Yes, in general, for the population is we tend to have larger neighbors because they rely on more than or in population A, generally likes are larger, so we can let the features without too much errors. So in population B, it is a bigger population A difference.
Yeah, good question. Either there's a similar diagram for time to kids.
So sorry.
There's a similar diagram for time to kids.
Oh, I don't know, but I think that there is not, but I am not sure. Yes.
I have a question. You should be the scene should be moving.
Let's we cheer movies, but I couldn't which one. That's
About SCDs or extreme populating individuals.
Scientists here and or today I'm going to present you a spectral energy distribution for finger bleaching quasars and some implications of conditions that probability. So here we just quickly introduce for the image back. So my main focus is on the results, which we identify them using the RFP parameter, which is the relation between the iron emission and the beta. And this, when this ratio is larger than 1, we have we also have some indicators in the ultraviolet, aluminum silicon, silicon, and often we call these sources in many ways. We can call them forces according to the given one parameter, AC or A force or A for quarters according to the T. Also, like quasars, the quasars, or well, all of the charts they have a equation. So these kind of sources, AC forces, they trigger A for peaks on the elemental one. We can observe peaks on the spectrum. These peaks are mostly related on high polarization lines like carbon 4. And also we believe that this means not in the environment of the galaxy or even the intergalactic environment. So in this course, like the two of the symbols in P1, we did a study on the different components of sources and we found a locality, the range of 10 and 54 localities, which is like a high locality estimate. The suitable system of regulation in the singular region of the APA who help us explain like this high mechanism we are observing that is until today these are just 2 years working. By modeling an ACE or exit process or first what we are into is to study the environment of the lower region. And to do this, we use qualification model. And to use qualification model, we need to calculate what is ionized in the medium around. What is ionized in the clouds? So what ionized the clouds? The ionization continuum is that S. So that's why we model an SDE to model the product regions of a single relation source. We couldn't find any other SDE on the listener that will that model that has all the purpose of that. So our goal on this work was to create an SDE for a small B on observational data. And later on, to use this set to model the potential to see this model. So to begin with, of course, we need an example. We start this by searching on the literature for sources that were highly sources. We look on over 5,000 research, and only 800 of them were XC sources. So this is how rare XC sources are. Around 50% of the sources are XC sources. We then examine it on the worksheet to be sure of for more documented data. And we ended up selecting only 155 sources that were all XC sources. So 84 needs on the vector one. All of the samples provide us with the outer parameter and also the maximum HV. Most of the sources are AC sources, so they have like the parameter between 1 and 1.5, and only 1/3 of the sample are 84 sources. Also, most of the samples as well private bias. For set, we did this in 3 different stages. Modeling the gradient to unit provider, modeling the UV equation which is controllable between the expression, and modeling the X-ray data. The unit provided the 5% based on plasma fluidity from next. And we need all the needed to correct the absorption, and then we proceed to feed the data using regular linear regression techniques and cubics, cubics. Also, of course, we avoided the extrapolations, and we also use the synthetic spectrum from our 2013 to help a little the intraviolence. Using all the data we feed it in the using the data feeded from the radios being provided. We also estimated some parameters. We estimated luminosity, and also estimated the lux using an integer-based calculation. And these are the results we obtained. The mass is columns are very symmetrical histogram, and all of the sources, of course, they have a large amplitude parameter. For the UV question, these is observable. They're not a we don't have any genetic data in this region. We use models. We use made by companies. So we use equivalent models. To select these models, we use the mass, the total mass previous estimating the previous one. And we select an important model for the median of all the sample for the Q1 and the Q3, which is the 25% above and 25% below. These are some spoilers of our results. Here you can see the median, the Q3 and the Q1, and on the gray areas is where we connect the pivotal models with our medians and Q1 Q2. And if you look closely, you can see like a little step, and that's how smoothly or median with the pivotal and down models to be together. For the actual data follow power law, so we just went to search into more parallels to allow the data needed. And for the soft X-ray, the color catalog, for the hard X-ray, we use the Evans catalog, and for the X-ray above hard X-rays, we use some data available, which was like for the same option. So once we did all of these, we could put all together and create like a median set. But when we were putting all together, we saw that we have like a very variance equal source. So we use the ratio by Ganchi to see what was the difference between almost sample, and we could identify very wide range median and very loud sources. So for the very intermediate and very loud sources, they're just like a minority of sample, it's just 5% and 5%. So we could not estimate like a good median for the sample and be a model in the UV and everything else. So these are just like everything we could get on the right intermediate sources, which is the one above. There's something interesting because we can see there's a breaking point in the cylinder, which means something interesting. Also, Bulgaria 51 is a very high resource, and it's also a right intermediate source. For the radial sources, there are not we didn't have enough data to do something. We have a lot of holes, so that's it. Radio source we have. So for main result is focused on the right sources, which are high about, for example, and it's in water studies, and this is the sample that will be UV equation this for Google. So for median set is this one. Is the median of the 130 sources. The pink line is the median, all together with the net data, the waterfall model, the X-ray data, and active energy for the above or X-ray data. And the shadow, the gray shadow in the figure is a 25%, the Q1 and Q. So we can do comparison with ourselves, with our LCD, and you know that it is similar to the one by the one discussed in 2020, and it's very similar to the high accretion rate set on 2020. We also indicate a little on the most extreme among the streams in our samples, the A4 example. And we notice that as the iron part was increasing, also the infrared was increasing. This is also that has been discussed before by anybody in 1993. And as he discussed in that year, it is like a grown scenario with a bio and episode of star formation. And this is also an agreement with the evolutionary alone, where quasars are just like all, and there are in this particular sign of their evolution where they have like a lot of stuff going on right there. We also invest in the Quasar a lot using low conditions modeling, using also all the results coming out. And we've been getting results that are comparable with the actual ones. For example, for the given grid for carbon 4, we get like a unison parameter around -2.5 and a density around 12. It's in agreement with global parameters. And finally, for the first time, we model an escape for extreme occlusion process. In our sample, we identify very wide value to median and radiological process. Found these far infrared axis in our radiological sample, and also this high infrared axis is linked to a strong iron emission, which is to a large iron. You can find all of these in the ununified, and you can also find the SE available in digital form, the medium, which is the A9, the Q1, the Q3, as a normalized value velocity, and a lot of things we were doing by developing this work. And finally, the movie I want to recommend to you is Karla Garnica. It's a Mexican fictional movie, like also we do when we start working on this. There's also a book, and now there's also a series. The movie is from the 1992 is free. Thank you.
What special on extreme population can exist in high emission rates?
Yes.
Also the high emission.
Only to begin with the higher version rate.
How high is this? How high can the emission get this population? What are the getting rates?
The eddy conversion is always close to 1. Yes.
Yeah.
I wanted to ask you about this millimeter flatness. Is it based on data, or is there very few objects there?
For set, it's based on observational data. Most of it is observational data. Only the ultraviolet is not observational data. So if you use gas, so it's because there's no observational data there. That's why we could only focus on the white ones. And we could not do anything about the radar ones because there's not either. But on the 2 millimeter, there's like this breaking point that we still are figuring out to life there. But it's like this breaking point and is according to the model. We did nothing else. We just did like linear regression there. And nothing else.
Very nice. So would you say that all these are narrow? Yeah.
So do you have the other ones that are interesting?
Yeah, now I see. Yes, the one ones are yeah, yeah.
Comment on the speaker. Yes, we have a lot of sample of language. There. In actually, the extreme part of the placement part is still some population and population the 6 because of the migration and the higher densities. Another point would be expected. In fact, why we are finding is predicted because of the water program is just not part of it, not equal general. There's a much more advanced version of both the government 2019, which they apply on the super element system, effectively highlighting the importance of the wall license and X-ray parts go it highlights very fast. Effectively, SE changes a lot from the local populations more very city chips. It's very difficult to so these next activities can really be into parameters when we are trying to analyze So, any more questions? So we'll have our lunch break. You should do that. We have a message.
The highlights are the right. If you want to share photos, taking along the week, please do it there. And the second one is let's take the photo right now. We all this hour, so we release there.
Where do you have the experience? ¿Ve bien la luz? ¿Ya vino? All
Do we have to? Bueno, sí, pero nos mejor.
No, sí, pero entonces que no eres. Me ayudas. ¿Dónde la quieren? La adelantamos, todavía no lo bloqueas.
Mayor para esta.
No, es que no. ¿Dónde habías? Pero ¿qué tal con esto? Lo que te digo, bueno.
Ya está, no pasa nada. Uy, ¿quién no?